Section 4.2 is on page 215. Talks about polar equations and graphs. This is a very important section, one of my favorites, but it has a lot of information and you really want to spend your time on this. I'm going to follow directions 15 through 30. It says transform each polar equation into an equation in rectangular coordinates, then identify and graph the equation. So here, this is on page 227. Here, in this first batch of problems, we're trying to figure out what those look like. R equal 2, what does that look like? We did that back in section 4.1 toward the end, if you notice. Here we would square both sides. I have an option, either I multiply by r or square both sides. If I multiply by r, that will be a problem because then I have to deal with this. And remember, there are only 4 equations. X squared plus y squared equal r squared. Tan of theta equal y over x. X equal r cosine of theta, and y equal r sin of theta. So here I would square both sides. And I'll be looking at r squared equals 4. And I know that this is x squared plus y squared equals a 4. Now I want to sketch a graph of this. Well, I know how that graph looks like. That is simply taking a graph centered at the origin with a diameter of 2, and there it is. So I get out of this that r equal 2 is a circle with a radius of 2. So here, notice r equal f of theta, meaning there is an r and there's a theta in every equation, just like we know that y equal f of x. There is a y and an x in every equation. Now, if you remember back in the days, the exception was if one of those two values is missing. Then what does that mean? Well, here, if there is no theta, that means it's a circle. And what if there's no r? So here, if there's no theta, that means you're going to go to r equal 2. There's r equal 2. And you're going to rotate all around. Since theta is not present, that doesn't mean theta doesn't take any value. That means theta takes on all the values. And by doing so, you create that circle. Here, I notice theta is not present on number 18. Well, let me not worry about that yet. I'm sorry, r is not present. So here, I know that tan of theta equals y over x. And since they gave me theta, well, this means tan of negative pi over 4 equals y over x. And we all know what tan of pi over 4 is. Isn't that a negative 1? And if I cross multiply, wouldn't that mean y equal negative x? I know how to graph that as well. Y equal negative x is just a line that cuts the quadrant in half. And there it is. So we can, again, connect that theta equal negative pi over 4 if I rotate the negative pi over 4 using polar. Since r is not present, 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4. If r takes on all the values, then guess what? I'll trace that line. Now, if I look at this, r cosine of theta equal 4. Well, what does that look like? R cosine of theta, that's x. I know how that looks like. That's just a line, a vertical line. Well, in the rectangular coordinate, it seems really simple and straightforward, but let me show you what it looks like in polar line. So in the xy plane, this looks like a straight line, but here, this is really how this graph looks like. That's not working. Okay. It looks like this. Basically, 1, 2, 3, 4, and there it is. So this graph doesn't come up as much. Those two we do use a lot. This is all over the place. Here, if I want to convert, we did that already. Let's do it again. If I want to convert this, I will notice that, well, here, squaring both sides doesn't help because I need that to be r sin of theta. So I multiply this by r and this by r. That will be r squared, which is x squared plus y squared. And this is twice r the cosine of theta, which is y. That is x squared plus y squared minus 2y plus a number equal a number. Half of the middle number and squared. I'm completing the square, if you remember how to do that from back in the days. This is a circle with a center of 0, 1, and a radius of 1. And the circle looks like this. If you ignore the grid and just focus on the x and the y, you'll notice that that's just a circle. We know how to do that. But now we're tying that to r equal 2 times the sine of theta. And I'm going to show you a nice way of how to figure out all of these different graphs. I have a couple of more graphs I want to pick out of those before I go on and actually start about what to look for and how this is going to behave and all of that. And if I look at the last batch of problems that they want me to do, if I convert, that is r over the sine of theta equal an 8. I don't like that 8. That is r equal 8 the sine of theta. Now I could complete the square and do the work, but let me just guess what that looked like. Look at that problem right there. And look at this problem right here. Hey, they look alike. 2 sine of theta, well, that is 2 units. Coincidence? Well, let me check. If I multiply by r both sides, I'll get r squared equals 8r the sine of theta, which means x squared plus y squared equals 8y. That's y. And that is x squared plus y squared minus 8y plus half of them number squared, and that is x squared plus this is y minus 4 squared equals 16. Well, I know what that is. That's a circle with a radius of 4, and the center is 0, 4, and the radius is 4. So I'm going to count each of those as 2. This is 2, this is 4, this is 6. If I go up 2 units, 2, 4, and if I move 4 above, 4 below, 4 to the right, and 4 to the left, that would be my actual circle. Oh, that looks like an ugly circle. There it is. A circle like this. You know what? I don't like that at all. Here. Much nicer and better. Now, just something to connect. Nothing more. Just glance at that. Something I'm going to really be asking you to start paying attention to. When I look at r equal just a number, I know it's a circle with whatever that number is being the radius. When I look at r equal 2 times a sine of theta, sine is the y value, isn't it, so to speak? Sine, isn't that like the y value? So, I know this graph is wrapped around the y-axis. There's the y-axis, right? And it seems you have a diameter of 2. Let's see if that's making sense. If I look at this problem, I'm looking at 8, and again, sine seems to be the y, and this is 8. Well, let me see. Hey, wait a minute. That was an 8. That's matching. So if I pick one more just to see if I'm really getting this, and here they're asking us to convert, I'm just doing this to make sure that we're seeing how this works. And let me get a problem from the book. Let me get number 26. If I don't scale this back, can you guess what that graph looked like? I am guessing that this graph is actually this is sort of like the x-axis, and x equal negative 4, this is the negative x-axis, right? So I'm going to go in that direction. 1, 2, 3, 4 units. That's what it seems you do. And I'm going to draw a circle. And my guess the graph looks like that. And I could check if that's true by saying r squared equal negative 4r the cosine of theta. x squared plus y squared equals negative 4x. So x squared plus 4x plus, take half of the middle number, which is 2, and square it, and I'm getting x plus 2 squared plus y squared equal a 4. This is a circle with a center of negative 2, 0 and a radius of 2. Well, guess what? This is a center of negative 2, 0, and this is moving 2 in all directions. So that's really what I want to go for in the next part. Now I'm going to talk about in general how these graphs look like and proceed. Here are the graphs that you know how to do. We're going to have to deal with graphs that we should use polar because we don't know what they look like. So bear with me. I'm going to start with, if I happen to see a graph of r equal a, well, I know what that is. I really don't have to do much. I don't need to convert and do the x and the y and all of that stuff. All what I'm going to say is that that is a circle with a radius of a. Everybody's happy. If I see r equal a, the sine of theta, then I would know by now that I saw what I saw, I would know that it's one of two graphs. It is either, wrong key. I would know that it is either it's a circle with a diameter of a. Well, how would it be up there? If a is bigger than 0, if this number is bigger than 0, then this is kind of like the sine, and there's the sine, the y, and there's the y. And if a is negative, then y equal negative y, negative y would be wrapped around the negative y axis. And similarly, if I happen to look at r equal a, the cosine of theta, right? I would also know automatically it's one of two graphs. I would know that it's either going to look like one of these circles, or one of these circles. And again, from what I saw, I'm guessing the diameter would be a. And since this is the x-axis, if a is negative, negative x will be wrapped around the negative x-axis, and if a is positive, it will be wrapped around the positive x-axis. So that's kind of how I'm seeing those. Now, I want to look at what happens if you double the angle. What happens if you take a times the sine of n theta, or a times the cosine of n theta? It turns out that this would be an n-leaved graph, and I'll explain what that means in a minute. This is an n-leaved graph if n is odd, and it will have twice as many of those leaves or pebbles, whatever you want to call them, if n is even. Now let me see if I could fit that in front of it. That will look really nice. Oh, look at that. What do you know? Gorgeous. Now there are two more graphs I need to worry about and tell you one thing, and we start sketching all of those. If there is a phase shift, a vertical shift. Phase shift, this book doesn't deal with much. That really comes up in calculus a bit, not really. Majority of what we need is what you see right here. If I see r equal a plus b, the cosine of theta, then I'm going to know this graph is wrapped around, guess what? The x-axis. Well, but it could be one of multiple graphs. I'll show you how that works. This part is a bit challenging. And once we start graphing, then all of this is going to match what we know, hopefully. We'll see what that means.